or two, there are two identities. It's a sum and difference identity, but they're combined for cosine. Okay, so the first thing, so basically what this does is it takes, this allows us to calculate non-unit circle I don't know if I'm saying it right. Values of cosine using the unit circle. That's exactly. Okay. If you have your unit circle identity sheet, that's why I put them back to back. If you can pull it out, it'll probably help. Okay. And having a unit circle in front of you. All right. So the first step is seeing, let's say, 75 degrees. Okay. If you look at your unit circle, are there two angles that add up or subtract to form 75?
45 and 30.
Okay. That's an add. See, so we're going to split a non-unit circle angle to two unit circle angles and use those to solve for this value.
And 135 and 90.
135, it also is 135 minus 60. Yes?
Oh, yeah.
So either of those would work. But I'm going to show you how to use them. But the first step is to figure those kinds of things out. So you get a non-unit circle value. Split it into the non-unit circle angle and make it two unit circle angles, or form it with, I should say. Okay.
Okay, so it's not always going to be 75 degrees. It's just-
It might be 155 degrees.
Okay.
But the question is, can you make it a unit? Can you use two unit circle values to make that number? Okay. We can also do it in radians. So let's see. How about pi over 12? You might find it easier to convert first to degrees.
Right.
Okay, so this is an option. I would love for you to get used to operating in radians, so try to figure this out in radians. What's your common denominator? 12. Okay, can you put those in twelfths? So if you have the unit circle up here, pi over 6 is actually 2 pi over 12, right? And 1 pi over 4 is
2 pi.
3 pi over 12, right?
Making it 12.
And this is 4 pi over 12. And we have 6 pi over 12. Of course, that's 0. Okay, so can you combine any of those to make 1 pi over 12?
Subtracting from each other 4 degrees.
Yeah, so 3 pi over 12 minus 2 pi over 12, right? You see what I did?
Yeah.
No.
Subtract.
He made
Oh,
them have
yeah.
a common denominator.
So this is in twelfths, so if I turn these into twelfths, it makes it easy to see.
Right.
Okay. These angles are actually pi over 4 and pi over 6. Those are the unit circle angles that you're going to use. Yeah. Use the common denominator. Again, you can also split this into, those are equivalent,
What?
right?
You
Yeah.
took the 45 and the 30.
So pi over 12 is 15 degrees. A little easier to see, right?
Yeah.
Okay. So it's an option. But if you are given an angle in radians, you need to work it through in radians. Next to this, if you want to use degrees, I'm okay with that, but make sure you're practicing the radians because it is going to pay dividends. All right. So you think you can handle that kind of stuff?
Yeah.
No? Yeah.
Absolutely
Yes.
not.
All right.
As
So
long as we keep it in the first quadrant, as soon as we move out of that, without having to look at the sheet.
okay, here's what a lot of people are tempted to do. Okay, let's say cosine 75 degrees is 45 plus 30, right? This is a temptation. That is not valid. That is not
Correct.
going to give you the right answer. Okay?
Explain. Because
Because on the right side it'd be 2 from.
This is a function, right?
Yes.
We cannot distribute functions. It doesn't work.
Ah, gotcha.
Okay? So be very careful that you don't do this.
I need to work on it.
Right. You have to use the identity. Right. So the actual identity would be this. Yeah, I think it's. I'm gonna look just to make sure. Yeah, we got it wrong. Here we go. That's the identity.
Why can't we just leave it as a 75?
Because we don't have that on the unit circle.
We don't?
No.
What is the entire point is just
See,
to make it?
the point is, this is not on the unit circle,
So we're trying to make,
so we are making it a calculation that is on the unit circle. All those are on the unit circle, so you don't have to have a calculator. Okay,
Oh, okay.
okay, so the cosine of 45 degrees is,
hold
2
up.
over 2.
I forgot.
yeah, get those memorized, folks.
3 over 2 besides the x.
3 over 2.
Inside.
3 over 2. And then,
See all the numbers from the unit circle.
Yeah. Square root of 2 over 4.
So only two that are, like you have, are these two. 45 is always the same. Okay, then you finish your arithmetic here. Root 6 minus root 2 over 2. 4. That should be a 4. Because I can do fraction math. Okay, get root 6 over 4 minus root 2 over 4. And you're done.
2/4.
No, you're done. Root 6 and root 2 are not
compatible.
perfect squares. You cannot do anything with it. Okay. Not quite. Okay, so this is the cosine addition identity. There's also a subtraction identity. So if I were to do cosine of 45 minus 30, so keep in mind again, this is cosine at 75 degrees, right?
Yeah.
Okay, this would be cosine at 15, right?
Yes.
Okay, the only difference between this one and that one is plus sign.
Okay, so it's just fingers.
So this is cosine 45 cosine 30 plus.
Like just the word. What?
So it's the only difference. Change the sign, change the sign. All right.
He's freaking out, man.
That guy beat you up last night worse than it looked. Tough match.
Yeah, it was so blunt.
You guys ran into a pretty good team last night.
We did fairly good.
No, you battled. That's what you had to do. There's some guys squeak out wins. A couple of you are very close.
Oh, no.
Okay, so again, what's the answer going to be?
2.
Same plus. So that's cosine of 15, right? So good?
Yeah.
You can handle that.
Yeah.
I want to write down the identity in general. That's a C. S. You guys know what those letters are? Cosine fishy plus shrimp.
I was going to say fish plus B.
No, it's not fishy and shrimp. It's alpha and
Omega. It's beta.
beta.
Not theta.
Okay, so 2 more Greek letters to add in your vocabulary. Fishies and shrimps are alpha and beta. But notice we stick them both together, plus and minus. So the identity, when we write it out, we have both identities in the same statement. Cosine fishy, cosine shrimp.
It confused me when you say that.
Okay, cosine alpha, cosine beta, sine alpha, sine beta. Just keep this straight. There's a plus here. You use it with the minus.
Oh, okay, that's why.
See how you switch them? And you can write them both in the same statement.
Yeah.
If I use a minus here, I use the plus here. Okay? When we get Tuesday to the sign addition and difference, sum and difference identity, they'll actually stay the same with sign. Okay? But we're just bothering cosine. Okay. Here's a problem for you to work on right now. Then we'll move to a radians example. 165 degrees.
What is that?
Find the two values you split it into and do the math.
Does it matter if it's subtract or add?
No, you can add or subtract. It's your choice. You'll get the same answer out the back end.
Right? No.
And I will wander around and see if you need any help.
No. I mean, we could do 120 plus 45. 210 minus 45. No.
Hey, knock those toxic thoughts off right now.
225 minus 6.
No. Yeah, no.
What's 65? Yeah.
225 minus 60.
What did you do?
What am I doing? 145.
What's you?
Chase.
Always.
It's called
Chasing
Christian.
Christ.
What year? Jesus Lord.
See the porn.
You're terrible. Do you just want us to write out the formula or fully solve it out?
Solve it out. Okay, solve the whole thing. The more practice you get with the circle, the better.
So you want, is there time to do the degrees? How do you translate? Oh wait.
We're in degrees, so you're
Yeah, never
good.
mind.
Oh, wait, no. I was not expecting him to say no.
If it's in degrees, work with degrees. Yeah, that's fine. Go ahead.
I don't know.
What am I doing right now?
Good question to ask sometimes.
What is
That's what you drop on. That's what makes you
It's 120. Good, yeah.
What did you just do? Root 2?
Hey. Fishing?
Okay. Not today.
You should run clock again. You gave me the subject.
What'd you get, Tyler?
I will do it.
Oh, I lost it.
Nice.
You ruined that sneeze. Root 2 minus root 6 all over 4.
You should have seen the letter.
Check your signs.
Teaching boys.
No, it's negative root 2.
In the
Wait, it's
future.
negative root 2 over. Mine is root 6 over 2. 4.
I even gave them like 2 extra points.
I don't know, you said like
Really
12
good.
different numbers.
I literally right.
I feel like I really need to sneeze, but I can't.
Did I steal it first?
No, it's trying to read it.
Because I sneezed.
I was literally in the process.
Chase
I
I
took
was
the
in the
power.
process of sneezing, and you asked me.
You just let it go too long.
Stop.
Grants,
You need to
what numbers did you use?
I use 135 for everything.
What I do?
Come on, Christian.
Well, you can't really say that.
You had it written
Hey,
down.
Mom.
You could say
No, you
college.
You are Christian.
How was it? Oh, that's
Yeah, we were thinking of way much harder than one.
There's so many different things that we can use.
I want to see
Right?
if anyone did 2.
So that's what Rance used. Christian, what'd you use?
120 and 45.
120 and 45. Cade, what'd you use?
I used 120 and 45.
Probably the two most common that I saw. Anybody use anything different?
Could you use 220 and
I was going to use
60?
220 minus 60 is
225 and 60.
225 minus 60. Perfectly reasonable. Any of it.
Use them to college.
I don't care. The final answer is anybody get negative root 6 minus 2? Root 2.
Oh, no, never mind.
No? Everybody got this?
Why did you write?
Did you?
Okay. You can switch order here, doesn't matter.
Oh.
They're both negatives. Okay. Let's move to radians. And
So we'll just.
here's a popular one.
It's gonna give you back a score of that Precalculus.
You're bleeding on the thing.
I'm actively trying to see this, yes. I'm just gonna take your radians and convert them to degrees.
You guys want to work in degrees?
Problem.
I'll try to do it.
Are we doing it?
No, we're gonna go through it. Okay. Again,
When you do that, I see that.
I just lost all the knowledge.
Choose over by minus 150 is right now.
Would it be 2 times 12?
I did 5 times, 5 times.
Yeah, that would work.
again, convert everything to twelfths. 2 power 12
That is dead.
and
3 times.
3 power 12 works, right?
Oh my.
To those, and if you simplify in radians, that's power 6 and power 4. Right? You simplify those fractions.
Yes.
Again, okay. What degree measurement is that?
It's like 90, isn't it?
No,
It's 30.
90 is 6 power 12.
Oh, how is that?
Remember, 5 power 12 times 180 over pi converts.
That's
Oh, that
75.
Did we already do that problem?
Yeah.
Whoop, we did. We know the answer now. Same as this one, right?
Yeah.
Okay, but again, in radians, cosine power 6, cosine power 4, plus or minus.
Yeah, no.
Yeah, opposite. I think there's as much value in this as in practicing your unit circle as there is knowing the identity. Because I'll be honest with you, I don't ever remember this coming up in calculus. Okay. So, alright, so cosine of power 6.
He still can't.
It says
He still can't. Holy, you did this.
cosine power 6.
He's like trying to major.
Correct?
No.
Oh, wait, never mind. I was looking at it.
Power 4?
Square root of 2. Yeah. Square root. I did that.
This has to be,
Really?
right? Those always pair up together. And then power 4 is always,
Sneezing, they're sneezing.
right, so you get what, root 6 minus root 2 over, same answer as before. Think you can handle those?
Probably not.
I don't know if I can.
Yes, the 60 was not working.
He's just concentrating.
I don't know, but I'm trying.
His body is so scared.
Try this one.
It's not me trying anymore. Christian.
Oh wait, hold on. That's on the unit circle.
No, it's not.
Ready, set, go. Yeah, that gave me a gimme, didn't I?
How?
It's pretty
funny thing is half you probably would have still tried to do the identity. But,
Okay. 11 power 12.
You know, can you? Yeah, you could do that.
You could sneeze.
I ruined everything.
Dude.
So we can take.
About 15.
Multiply that, which is 22.
That's 15, man.
I don't know which two you add together.
Yeah, 7 plus
7 and 4, but that won't give you 12 because then you multiply them together.
Anybody found an answer yet?
No. But that
Can you
will
use
give you
0?
11 12s, you know? That gives you 11 6, not 12.
Is this all?
No.
Can we use the same rating?
Again, convert to 12s.
I'm going to convert this to
Let's see if there are a couple of them that add or subtract. Find it.
14 minus 3.
So that's 2 pi over 3 and pi over 4, which makes,
Eight over
We
12.
can make it 16.
3 over.
we got somebody that has a floor. Keep looking. The other way is to convert it to degrees. And you try. It's there. Yeah. Jerry, when are you going to learn that I know everything?
Oh,
You do. I'm just kidding. Bold statement, not true.
You can use 135, 8
Dude, it's just 165 degrees again.
No, he just gave us very good, so now we know the answer.
There's only so many of them, and I don't want to ruin your homework.
Ah, sure you're in our homework. No, that's not
Dude,
it's gonna be
I
20
know.
minutes.
Did you even think that
You want homework, is that what you're saying?
Did you think
You
that?
want the homework? Okay. You can go out.
Okay, are you done?
We do the homework.
Why not?
Because there's no like, it's not proportional to anything on the unit circuit, because it's 11. Like,
You're wrong.
Okay,
You gotta add to them.
You haven't been listening to anybody's conversations.
okay.
Try 135 to 30.
Convert it to degrees and try.
We're 11 over pi to over 2.
11 pi over 12, convert it to degrees, and it will become plainly obvious.
I did it wrong.
You could have hit
Yes. So those are some hits, but
He stole one from me. What did he say? He stole one from me.
Oh, yeah.
we'll do that.
I think that works.
Does it though?
He looks like this is back of your head. The way he was looking
8 pi over 12,
Yeah, I don't know about it.
3 pi over 12.
Yeah.
8 plus 3 is?
225.
Oh.
Again, you can convert it to 165. This is 120 plus 45. Again, it's 165. We've already done it, right? But I want you to get used to working in radians. So it's okay to convert to figure your numbers out, but please work it in radians. Work that unit circle in radians so you get used to those values. Because that's where most of you bonked on the unit circle quiz. Your next opportunity to make that grade up, the unit circle quiz grade, that's gonna be your big money right there, is learning that. Okay? It will replace your old one. Like every time we do it again, it replaces your old grade, so. Opportunities to improve. What's the answer? Same answer as before?
Yeah.
That's a 4. Okay, any questions? Okay, there you go. You're welcome.
Is it? Thank you. You're not, no second guessing.
If you want, this is sine and tangent. So Tuesday we'll go over sine and tangent. Sine's very similar, tangent's a little bit more messy, but if you want, like, to start, you can do the spiraling, right? The spiraling will be on here.
I actually kind of want yeah, I know. I've been trying to wow.
Okay, most of this is spiraling. Like, you only got 5 new problems. A lot of old. This is not due until Wednesday. Okay, so. Like I've been telling you, I'm giving you very few new problems a day so that you can focus on the ones that you have.